Welcome back, Chemistry 30. This is the third and last part of balancing by using oxidation numbers. So we looked at what happens with net ionic solutions that are in acid or base solutions, and we're about to look at these examples here. So use the oxidation number method to balance the following net ionic equations. So we're told 15 is in an acidic solution, 16 as well, 17, it's a base. And as I mentioned, sometimes difficult to figure out which side OH and which side H2O is on because they both have oxygen. So in this particular question, a hint is given. Hydroxide ions will be on the right, water molecules on the left. All right, so let's take a look here. So the first one, we have this. So I'll maybe pause the video here and you write down the oxidation numbers, figure out the change, make the change equivalent, and see if you could balance it at least up into the point in which we have to add H2Os and H pluses. Okay, so maybe pause the video now. All right, if you had a chance to do that, the oxidation numbers look like this. Oxygen, of course, is more electronegativity negative than N, so -2. And you can see how that all works out. Sulfur goes from -2 to 0. It's becoming more positive, so it's oxidized, and that change to go from -2 to 0 is +2. And over here, nitrogen is changing, going from +5 to +2. It's getting more negative, so it's reduced, adding electrons. And to go from +5 to -2, that's a difference of -3. So 5 minus 3 gives us 2. And of course, 3 and 2, the lowest common multiple there is 6. So 3, 2, so I'm going to have 3 S's, 2 N's. So simply putting those numbers here, 3 S's, 2 N's. On the right side it works the same way, 3 S's, 2 N's. Okay, and we're told it's an acidic solution. If we take a look at what we have here, we have 6 O's, 2 O's. Now assuming that we can't change anything that's here, we can only change H2Os and H pluses that we add on. We're short of oxygens on the right-hand side. So that kind of gives you a hint. Maybe that's where we have to add the water molecule and the H pluses on the left. Okay, because you can only take a look at oxygen. We're short. We can't change what we have here. So yes, add H2O on the right is the hint I give because there's a shortage of oxygen on that side. So I added my H2Os, and that means H pluses are on the left. So I have 6, 2, so I'm short 4, so 4 H2Os, that's going to give me a total of 8 hydrogens. I have 6 hydrogens here, so that leaves 2 right there. Okay, so a little tricky. It's basically the same thing though up until this point in which you add H pluses and H2Os if it's acidic, or if it's basic, H2Os and OH minuses. Okay, here we have number 16. We're told it's an acidic solution again. And look at that. We have oxygens on the left, nothing on the right. So we're going to use the same hint here. We're going to have to eventually add H2Os on the right to balance oxygens likely. All right, so assign oxidation numbers, figure out the change, make the change equivalent, and see if you can get to this step in which you have it preliminary balanced. Okay, so I'll pause the video now. Okay, if you had a chance to do that, here are the changes that we see. So the oxidation numbers, as you can see, so chromium is going from 6 to 3, so it's getting more negative, it's reduced, and that change, 6 minus 3 gives me 3, there it is. Iodine, -1 to 0, so it's becoming oxidized because it's getting positive, +1 is the difference. So to make it, so 3 and 1 both go into 3, so if I triple this, I'll have what I need. So as we can see here, if we add our numbers here, now we have 2 chromiums here, so we're going to have to add a 2 here just to balance the chromiums. I'm told here that I need to have a 3 in front of here, so 3 iodides. Yes, and look at here. To have 3 iodines, 2 times what is 3? 2 times 1.5 is 3. Okay, so that kind of gives you an idea as to how to balance it first of all. And of course, as I mentioned, I'm short of oxygens on the right, so that means my water molecules are going to go on the right. Okay, so I add them there. Now, the iodine's not affecting anything else, so I can make this get rid of the fractions automatically. I don't have to double everything in the equation since I have iodine by itself, times 2, 6, times 2, 3. So I won't be changing anything by doing that. And of course, I had to double it because I'm doubling the chromium on this side too. So you can kind of look at it like that. Now, adding my H2Os on the right, I have 7 here. So hopefully 7 will work here. If I put a 7 there, that gives me 7 O's. That gives me 14 H's. 14 H's. There we have it, folks. That was a tricky one. And the last one that we're told is a basic solution. So again, I'll pause the video while you figure out the oxidation numbers, figure out the change, and see if you can balance it before adding the OHs and H2Os. And of course this one, it's a little tricky. You'd have to kind of guess and check. Do we have OHs on the left or right? We have to try both ways. But here, to save time, hydroxides are going to be on the right, water molecules on the left. So go ahead and do the preliminary balancing first. Okay, if you had a chance to do that, this is what you would have come up with. Okay, so iodine is going from -1 to 0. So it's getting more positive, it's oxidized, -1 plus 1 is 0. Manganese going from +7 to +4, it's getting more negative, so it's reduced. 7 minus 3 is +4. And 3 and 1 both go into 3, so we're going to have to triple this. Okay, so we do that. So we need to have 3 iodides, and of course 2 times what is 3? 2 times 1.5 is 3. Okay, and we were told a little hint here. Hydroxide is going to be on the right, H2O is on the left. So if we do that, and of course to get rid of this fraction, since we have iodine by itself, we can just simply double that and double that without doubling everything else, and we can make it work. So 6, 3, and of course OHs. If I look here, what I'm going to have, this is a little tricky. So I have 4 here, and plus 2 is 6. 4 plus 2 is 6. 4 H's, 4 H's. All right. So there we have it, folks. That one's all balanced now. And if we go back and just finish this off, the oxidation number method is convenient for balancing most redox equations, but you can see the next, okay? And then we won't have time to do the next one, but we'll just simply end off things here. So the assignment that goes along with this is a study guide. So go ahead, do that, and then hand that in. All right? We'll see you again.